Now we consider an attack against the DNS system, the DNS spoofing. And this is an attack. We have Alice, and Alice wants to wants to find some information from Wikipedia. Alice knows the domain name of Wikipedia, www.wikipedia.org. But what she needs to interact with Wikipedia web page, she needs the domain, she needs the IP address of this domain name. And to get the IP address, the DNS client requested from the ISP, and typically Wikipedia IP address is in the cache of the internet service provider because Wikipedia is famous and many people consulting it. So in the DNS cache, there is the IP address corresponding to this domain name. There is the IP address 2.8.80.154.224. So, and now Alice can contact, the browser of Alice can contact Wikipedia, and she sees the real Wikipedia web page, and she can start to give in something. Here are some fields, for example, to ask questions and find information. Now let's consider the attack. There is a bad guy, Mallory, and he manipulates the cache of the domain name service. Of the cache of the internet service provider, the DNS cache, and puts in, instead of the original IP, this wrong IP address, 39.99.99.99. So everyone who is requesting the information in future, what is the IP address belonging to the domain name of Wikipedia, will get answer 39.99.99.99 instead of the original number. This attack works and can be successful because the domain name service is using UDP as a transport protocol. You remember, UDP has no security features, so DNS cannot find out whether this is an information it's received from another DNS server, or whether it's an information which was given in by Mallory in such an act of manipulation. UDP has no possibility to check this. So here, to perform such type of attack is not so difficult. So now, when Alice restarts and wants to get, by means of the domain name service, the IP address of the domain name www.wikipedia.org, instead of the right number, she got this number. This number, which was faked by Mallory. Now, Alice cannot recognize this. Alice is using, because the domain name service cache give her the IP address belonging to the wikipedia.org, and she reaches this page. At the first glance, it looks like the original page. But if you see in more detail, here the user is asked to enter credit card number, to enter security code, expiry date, and others. This is the manipulated site. This is not the right Wikipedia site. This is the site Mallory showed with a different IP address. And if Alice is not very careful in looking, she reaches this page, it looks like Wikipedia, and you remember Wikipedia asked for some donation. So a naive user starts to give in personal data here. But of course, this personal data are not sent to Wikipedia. This data are sent to Mallory, to the attacker. So you see, a problem is that in the domain name service cache, in the domain name service communication, since it is based on UDP, there are no security features and manipulation is easy. Exactly this attack, to avoid this attack, the Secure DNS was introduced, DNSSEC. It was introduced standardized in the RC 2535, and it provides means to exactly find out whether the message is a fake or not. And this is organized by means such RRS, such resource record sets. The record sets, they provide evidence of where the data comes from. The method that's used is public encryption, so there is a public key distributed, and by means of the public key, the signature can be verified of the sender of the IP address that's assigned to a domain name, and in this way the authentication of the transaction is secured. I mentioned already methods, the cryptographic methods that's used is the method of digital signature, and this is how such a resource record set looks like. We have here the information that for the internet service, the wikipedia.org domain name is associated to this IP address. But then, in addition, we have a key and we have a digital signature. And the information are received by Alice in the following way. Alice wants to contact the web server of Wikipedia.org. On the one side, she gets information from the domain name server, which tells her the assigned IP address assigned to the Wikipedia.org, as well as Alice gets an information from the top-level domain name server, and this top-level domain name server gives her back the public key from the Wikipedia.org. This public key is needed to verify a digital signature. A digital signature, that's something that is encrypted with a private key. In this case, it is encrypted with the private key of Wikipedia.org. By means of the public key, Alice comes into the position to be able to verify whether this information she got from the domain name server, whether this information is really coming from the correct domain name server, or whether it's come from an unauthorized source. So the domain name server gives back the corresponding IP address, the name, wikipedia.org, together with a digital signature. So here, from this source, Alice got the public key, and by means of this public key, she can check the information she got from the DNS server. It was a signed name, and by means of the private key, she can unencrypt the signature and can see really that's the right domain name, Wikipedia, and she knows now the information she got about the assignment of Wikipedia, and the domain name and the IP address is correct.